All right, so let's go over the 6th grade Unit 5 test review. Question number 1, does this equation show an additive or multiplicative relationship? Well, I have y equals 7x, and that's the same thing as 7 times x. And so because it's 7 times x, that will be multiplicative. Number 2, additive or multiplicative, I have y equals x minus 7. Well, x minus 7, as we talked about in class, is the same thing as x plus negative 7, and so that is going to be an additive relationship. Number 3, I have 0.5 times x, or half x, or 5/10 x, and again, since 0.5 or 5/10 is my coefficient, it's the number in front of x, it's the number being multiplied by x. So I have half times x, and so this will be multiplicative. Number 4, which axis represents the independent variable? And so if we remember dry mix, my y is my dependent, and so my x-axis is my independent. And so if I remember dry mix, I'll be able to quickly tell that the x-axis is independent. All right, so apples are priced at $1.50 per pound, and I need to write an equation that represents the cost C of buying A pounds of apples. A couple ways to approach it. One, I could think, oh, well, if it's $1.50 per pound, well, then that means that it's going to be multiplicative. If I'm not sure that I recognize that, I could make a table of values. See, if I buy 1, it's $1.50. I buy 2, it's $3. 3 at $4.50, 4 at $6, and then determine if it's additive or multiplicative. So a couple ways to approach it. I think a lot of you will recognize right off the bat that that is going to be a multiplicative relationship. And so then I just need to know I have my pounds and I have my cost. And so does my pounds depend on my cost, or my cost depend on my pounds? And so we know my cost is going to depend on my pounds. So the more pounds I buy, the higher my cost will be. So in that case, then my cost is, since it's dependent, is going to be my y, and my pounds is going to be my x. And I know it's going to have to be y equals, since it's multiplicative, mx is my format. Well, my y value is c. So c equals m times a, or because I know my m value is $1.50, then it will be c equals $1.50a. Write that better. All right, so c equals $1.50a would be my answer, and let's see if that makes sense. My cost is $1.50 times how many pounds of apples I buy, and that does make sense. So there's my answer. Question number 6. We need to complete the table to show how much money Miss Hampton spends on a babysitter. And so I need to figure out, is this multiplicative or is this additive? Well, so if I have 2 then 24, how do I get from 2 to 24? I'm going to either add 22 or I'm going to multiply by 12. 3 to 36, I add 33, or I multiply by 12. 4 to 48, I either add 44 or I multiply by 12. And oh, look, multiplying by 12 is my constant, so it is multiplicative, and my m value is going to be 12. So let's see, it would be y equals 12x, and so my process to fill this in, my y is 24, so 24 equals 12 times 2, 36 equals 12 times 3, and so on and so forth. Or I could say, well, if I found out that it's multiplicative, 48 equals some number times 4, 60 equals some number times 5. Well, what times 4 is 48? Of course, that's 12. What times 5 is 60? Of course, that's 12. So 2 ways of figuring out how to complete the table, and you can just use whichever one works best for you. Question 7. So it says here, write an equation, either y equals mx, that's my multiplicative, or y equals x plus b, so there's my additive, that describes the relationship found in question 6. Well, we actually already did that just while we were solving it, so it's right there. So I'm just going to rewrite it again, which is y equals 12x. Number 8. Write an equation to represent the relationship shown in the graph below. And so, again, it might be helpful to make a table of values. And so, gallons of gas, so that's going to be my x value because it's on my x-axis. Here's my y-axis. And my x-axis, or my x value, is my independent. Independent always goes on the left, so gallons on the left. And then miles on the right, because that's dependent, or my y on the right. And so when, let's see, so at 1, then it's going to be 30. So at 1 gallon, I have 30 miles. At 2, I have 60. And you can pick any points you want. So even if we went all the way over here to 4, and 120, that's still fine. And so once we've done that, how do I get from 1 to 30? Well, I can add 29 or multiply by 30. How do I get from 2 to 60? I can add 58 or multiply by 30. How do I get from 4 to 120? Well, I could either add or I could multiply by, so yeah, same thing, multiply by 30. And so there we go. So I know I'm multiplying. It's multiplicative, plus it goes through the origin. So if it goes through the origin, then I know it is multiplicative. So it's going to be y equals mx format. And so y equals, well, I'm changing by 30 each time. So y equals 30x. Question number 9. A district park maintenance has a budget of $55,000 annually. So far, $19,854 has been spent. Write an inequality to find m, the maximum amount that remains for the park. So, if it's maximum, then can it be greater? No. Can it be less than? Yes. Can it be equal to? Yes. So less than or equal to, and so we need to know what this is going to be. So if I've already spent $19,854 and I can still spend m, but that needs to be less than or equal to $55,000. And so there's my inequality. All right, number 10, which axis represents the dependent variable? So again, dry mix. And so my dependent variable is my y-axis. So there we go. And we're ready to go to number 11. Which of the following problem situations can be represented by the inequality 7x is greater than or equal to 49? So greater than or equal to 49 is what we're, so that's the key right there. So we read through here, we see less than. Well, no, not less than. More than, well, we do have greater than, but also equal to. At least. So at least means that's a minimum. So that means that I can have equal to, or I can have more, but I cannot have less. So, okay, that seems to match. And then at most, that's my maximum. So if it's at most, I can have less, I can have equal to. So less than or equal to, no. So the only one that even matches is C. And so that's going to give me my answer. Question 12. Problem situation can be Solve using the inequality x plus 35 is less than or equal to 70. And so reading through these here, Dusty put 70 cups of yogurt in the refrigerator and he gave 35 away. So that'd be 70 minus 35. Doesn't really even fit what we're doing. 35 in the refrigerator, bought 70 more. So that would be 35 plus 70, not really matching our inequality. He put 35 in his refrigerator. The maximum capacity of the refrigerator is 70. How many more cups can he fit? It might work. Let's see. So I put 35. I'm going to add some more. I'm not sure how many. So I'm going to add x plus my 35. And that could be a maximum. So it can be less than 70. It can be equal to 70. And so, that does match. So that one looks good so far, but let's read the last one to make sure. Dusty bought 70 cups. The maximum capacity of the refrigerator is 35, so it's a maximum of 35. Well, that's not at all what this is saying. So then my correct answer is going to be C. Question number 13. So this one is one that we did on our the task cards. Based on the table above, which statement is correct? And so we look here and we see the value of a computer is falling as time goes on. So as my time increases, my value decreases. And so we see here a computer becomes less valuable as time passes. Well, yeah, that looks like what it's saying. The longer a computer is owned, the more valuable it becomes? No, because it's decreasing. The graph is actually going down, so we know that's not true. The less valuable a computer is, the shorter you should own it. So the less value, so that would be this way. The shorter, well, no, that's not what this is saying. So no, and then the more valuable a computer is, the longer you should own it. Well, that would say that the value depends on the time, and we know that that's not the case. Or, well, I mean, it is the case, but it's not what we're looking at here, not the case of our graph. So the value does depend on time, but it's not saying that the longer you should own the computer, the more valuable it is. So that's not what the cause is. So A is going to be our best answer. Question 14, list the dependent quantities in the table. Well, my x values are on the left, y values are on the right. My x values are independent, y values are dependent. So all of my dependent quantities are going to be 750, 1125, 1875, and 30. Question 15. A moving company is able to move 50 boxes per hour. Write an equation to represent this relationship. And so, again, 50 boxes per hour. Some of you will recognize that that's multiplicative. Others may have to make a table of values, find out, well, in 1 hour, it's 50 boxes. 2 hours is 100. 3 hours is 150. And then look at it and say, okay, yeah, that is multiplicative. Once we've done that, we know that it's going to be y equals mx. Well, my m value is already given to us, so y equals 50x. Question 16. Groceries are delivered by a local service. Their charge is shown by the equation below. Which table of values represents this relationship? So I have additive relationship. So my y value, which is c here, and then my x value is g. So g plus 8 gives me c. So 11 plus 8 is 19. Okay. 13 plus 8 is 21. 15 plus 8 is 23. 17 plus 8 is 25. So let's look at B. 12 plus 8 is 20. 18 plus 8 is 26. 25 plus 8 is 33. And then 28 plus 8 is 42. No. So then 10 plus 8 is 80. Nope. 22 plus 8 is 30. 30 plus 8 is 38. 34 plus 8 is 40. No. All right, so then our answer has to be A. Question 17. A student group is organizing a walkathon for a fundraiser. Students are asking people to pledge 10 cents per lap. So we can see that that is multiplicative. And if we can't, well, how do I get from 12 to 120? It looks like I'm going to divide by 10. 24 to 240, divide by 10, divide by 10, divide by 10. So, okay, well, yeah, that makes sense, 10 cents. So dividing by 10 and multiplying by 0.1 or 1/10 is the same thing. So then my y equals 0.10 times x. Or because my W in M, so I could say that M, the amount of money pledged, is 10 cents times the laps walked. Questions number 18 through, looks like all the rest of them are going to depend on this graph here, or come from this graph. So, is the number of rotations dependent or independent? How do we know? Well, rotations is on my y-axis, minutes is on the x-axis. So because it's on y, it's going to be dependent because, well, dry mix tells me that my y-axis is dependent. How many rotations will there be in 4 minutes? So I look here, 4 minutes. And then there is 80 rotations. How long will it take for 40 rotations to occur? 40 rotations, whoops, I passed it. 40 rotations to the line, and that's going to be 2 minutes. And then true or false, the number of rotations depends on the number of minutes. Well, we already said that rotations is dependent, so that would be true. And there you go. Test review.